Welcome to our YouTube video on design patterns. Design patterns are essential in software development, offering solutions to recurring design challenges. They provide proven blueprints for building flexible, maintainable, and high-quality software. In this video, we will explore the different categories of design patterns: creational, structural, behavioral, and architectural patterns. Each category addresses specific aspects of software design, from object creation to system organization. Design patterns are a crucial aspect of software development that provide solutions to commonly occurring design problems. They serve as proven blueprints for creating robust, flexible, and maintainable software systems. Design patterns encapsulate best practices and expertise accumulated over time, enabling developers to leverage them to build high-quality software. In this video, we will delve into the different categories of design patterns: creational patterns, structural patterns, behavioral patterns, and architectural patterns. We will explore their purposes, benefits, and real-world applications. Creational patterns. Creational patterns focus on object creation mechanisms, providing flexibility in creating objects while decoupling the system from specific classes or implementations. These patterns aim to ensure that the process of creating objects is efficient, extensible, and easily maintainable. Singleton pattern. The singleton pattern restricts the instantiation of a class to a single object, ensuring that only one instance of the class exists throughout the application. This pattern is useful when having multiple instances could lead to issues, such as resource conflicts or when a shared resource needs to be accessed uniformly. Factory method pattern. The factory method pattern defines an interface for creating objects, but allows subclasses to decide which class to instantiate. This pattern enables the creation of objects without specifying their concrete classes, promoting loose coupling and extensibility. Abstract factory pattern. The abstract factory pattern provides an interface for creating families of related or dependent objects. It allows the client to create objects without specifying their concrete classes, facilitating the creation of objects that are designed to work together. Structural patterns. Structural patterns focus on the composition of classes and objects to form larger structures. These patterns help define relationships between objects, ensuring flexibility and ease of modification. Adapter pattern. The adapter pattern allows incompatible interfaces to work together by converting the interface of one class into another interface that clients expect. It acts as a bridge between two incompatible interfaces, enabling them to collaborate seamlessly. Decorator pattern. The decorator pattern dynamically adds behavior to an object at runtime by wrapping it in a decorator class. It provides a flexible alternative to subclassing, allowing objects to gain new functionalities without altering their original class structure. Composite pattern. The composite pattern represents a tree-like structure of objects, allowing clients to treat individual objects and compositions of objects uniformly. This pattern is particularly useful when dealing with hierarchical data structures. Behavioral patterns. Behavioral patterns focus on the interaction and communication between objects. These patterns define communication patterns and the delegation of responsibilities between objects. Observer pattern. The observer pattern establishes a one-to-many relationship between objects, where changes in one object trigger updates in its dependent objects. It allows objects to be loosely coupled, ensuring efficient communication, and reducing dependencies. Strategy pattern. The strategy pattern defines a family of algorithms, encapsulates them, and makes them interchangeable. It enables clients to choose algorithms at runtime, promoting flexibility and ease of modification. Command pattern. The command pattern encapsulates a request as an object, allowing clients to parameterize clients with different requests, queue or log requests, and support undoable operations. It decouples the sender of a request from the receiver, providing flexibility and extensibility. Architectural patterns. Architectural patterns focus on the overall structure and organization of a software system. These patterns provide guidelines and high-level structures for designing large-scale applications. Model View Controller, MVC, pattern. The MVC pattern separates an application into three interconnected components: the model, data and business logic; the view, presentation layer; and the controller, handles user input and updates the model and view. It promotes separation of concerns and enhances maintainability and extensibility. Model View Model, MVVM, pattern. The MVVM pattern is a variation of the MVC pattern that is particularly suited for user interface development. It separates the user interface into three components: the model, data and business logic; the view, visual representation of the data; and the view model, mediator between the model and the view. This pattern enhances testability, reusability, and maintainability of user interfaces. Microservices architecture. The microservices architecture is an architectural pattern where a complex application is divided into smaller, independent services that can be developed, deployed, and scaled individually. Each microservice represents a specific business capability and communicates with other microservices through well-defined APIs. This pattern enables agility, scalability, and fault isolation in large-scale systems. Event-driven architecture, EDA. The event-driven architecture is a pattern that focuses on the production, detection, consumption, and reaction to events within a system. It emphasizes the loose coupling and asynchronous communication between components, enabling scalability, responsiveness, and flexibility. Events drive the flow of data and trigger actions across the system. Real-world applications. Creational, structural, behavioral, and architectural patterns find applications in various domains of software development. Enterprise applications. Design patterns help in developing scalable and maintainable enterprise applications by providing solutions for creating objects, structuring code, managing interactions, and architecting the system. Web development. Patterns like MVC and MVVM are widely used in web development frameworks to separate concerns, enhance code reusability, and provide a structured approach to building web applications. Game development. Design patterns are valuable in game development for managing object creation, handling game states, implementing AI behavior, and structuring game systems. Distributed systems. Architectural patterns like microservices and EDA are essential for developing distributed systems where scalability, fault tolerance, and modularity are crucial. In the end, we can say that design patterns serve as powerful tools in the hands of software developers, providing proven solutions to common design problems. Creational patterns focus on object creation, structural patterns deal with composition and relationships, behavioral patterns define object interactions, and architectural patterns guide the overall system structure. By understanding and utilizing these patterns, developers can create software systems that are flexible, maintainable, and scalable across various domains and industries. Thank you all for watching. If you found this video helpful, please like and subscribe to our channel for more exciting content. And don't forget to leave any questions or suggestions in the comments section below. Until next time, happy coding!